Good afternoon. So again, Ed Turkel, HPC strategist for Dell EMC. I'm going to do hopefully a quick presentation, just talking about some things that we're doing. We're really focusing a lot on sort of next developments and on the way that we're collaborating with our customers to enable us to grow in HPC. It was very nice to see the numbers this morning. Thank you, Earl. So, we've been seeing very strong growth in our HPC business as represented in the numbers that Earl talked to us about. And also, throw a little, with the obvious relationship with IDC historically, just the minor detail that Dell EMC is #1 in servers and #1 in storage as per IDC. But we've been on a continuous path with HPC. I mean, Dell was relative to some of the other vendors in the room, came to the HPC world a little bit later. Our first HPC cluster was in 1999 at the Cornell Theory Center. But we've been growing ever since then and been developing, we think, leading edge solutions all along. Of course, a very important part of our growth has been a very special relationship that we've had with TAC, and Melissa's around here someplace, hiding in the back. Noting what we're doing there, and certainly the new Frontera system has gotten a lot of attention, and I think appropriately, with the great work that TAC is doing on it. I should point out, quick status update, gear is being delivered even as we speak. Melissa's going like this. She was the only one allowed to be here because the rest of them are stringing cables and wheeling racks in and so on and so forth. But I also wanted to highlight a couple of other systems that we've been delivering. Folks who've seen me present here before have seen this slide before. Our strategy hasn't really dramatically changed. We talk about advancing HPC, which is the things that we're doing around the technology. And that includes things like our HPC and AI Innovation Lab. This is our sandbox where we have a top 500 class system, the Zenith system, as well as a variety of other technologies where we're testing the latest and greatest technologies from our partners. Intel talked a little bit earlier about introducing the second generation Intel Xeon scalable processor. We all know the code names. And so we've been running that in the lab. We've been running HDR for a while. We're running next generation AMD processors in there. We have NVIDIA GPUs before anybody else gets them in there to do testing to be able to make sure that we can incorporate those into our solutions. And then our solution focus is around what we call democratizing HPC. This is taking technology and then translating it into when a customer comes to us and says, we need a solution to be able to do structural mechanics or to be able to do genomics or whatever, we can then turn around and say we have developed solutions, reference architectures, if you will, on how to put together a configuration for that purpose. And we'll do benchmarking on it so we understand performance characteristics and how to configure those systems at the right level for what the customer requires. And then optimizing HPC is really the broad portfolio that we bring as not only as Dell EMC, but as Dell Technologies that we can bring to bear in the HPC market. And that, I think rather unusual that we can do everything from client systems all the way out to the cloud. So some of you may be running Dell laptops. We can do that all the way out to we have our own cloud service called VirtuStream that related to some of the medical discussions that we've been having is one of the largest cloud services with HIPAA compliant medical data management capabilities, and that's offered as a commercial service to our customers. And of course, in there is also little things like VMware. So again, being able to provide cloud services as private cloud. A large number of our enterprise customers are running VMware, and we're working with them to enable the VMware environment to run HPC applications, okay, minimizing the performance hit associated with a virtual machine, while also providing hardware, direct connection to the hardware to run GPUs and so on, run InfiniBand in that kind of an environment. Some of the more recent things on the advancing side, we continue to expand the innovation lab. Again, latest technologies, we're growing the Zenith system and so on. We've added to our HPC centers of excellence. You'll see a slide on that in a minute, adding CSIRO in Australia. Under democratizing, we continue to add new and updated what we call ready solutions for HPC and AI. So these are very closely coupled together. It's very unusual these days for us to sell an HPC solution that doesn't have some element of AI in it. And again, certainly all the systems that I'll highlight in a minute are true of that. I'm going to talk also a little bit, well, we also had the ready solutions for Lustre and NFS based on a new storage array called the PowerVault ME4, which is an RBOD directly targeted for resilient Lustre configurations. We collaborate with our customers. As I mentioned, I'll talk more about the collaboration with the University of Cambridge on the data accelerator. And then under optimizing HPC, we've delivered new systems using direct contact liquid cooling in our partnership with CoolIT, as well as the first production HDR system in the world, delivered obviously with Mellanox. I noted new upcoming systems on here, which was because I didn't want to put on the slide that we're introducing the new systems based on the Intel Xeon Scalable, you know what I mean. I didn't want to write that on the slide. I didn't want to pre-announce from Intel, but since they were all actually introduced just today. So again, a couple of the new systems that we wanted to talk about. University of Michigan, the Great Lakes system, is the first HDR system on the planet, production system. The Pitzer system at the Ohio Supercomputer Center is our first direct contact liquid cooling solution, again, working with CoolIT. And you all, of course, know that the Frontera system is also going to be a direct contact liquid cooled system, also in the collaboration with CoolIT. We were just talking about cloud a minute ago, University of Cambridge. We built a new system. We've been collaborating with them for a while on cloud. They're a big proponent of OpenStack for HPC. They work closely with a company called StackHPC, which is a small consulting firm in the UK, focused specifically on the use of OpenStack and HPC. Stig Telfer, who's the CTO of StackHPC, is the chairman of the OpenStack Scientific Working Group. Again, working on developing new standards for OpenStack and the extensions to it to make it more useful in an HPC environment. I mentioned supercomputing whales partly because I just love their logo. And Martin Guest, who some of you may know, has been around for quite a while, presented at our HPC community meeting back at ISC in June. And we asked him to say the name in Welsh, and I won't even begin to try. So I mentioned the HPC Centers of Excellence. This, again, is our formal mechanism to collaborate with some of our leading customers around the world. And so the idea here is to formally collaborate. We have specific sort of statements of work with each of the members in terms of how we work together. And in many instances, they'll develop new solutions that we can leverage. In some instances, they're just testing new technologies that we can then leverage the results of that. So not surprisingly, TAC is on here. The HPC and AI Innovation Lab becomes part of this. We work closely with the San Diego Supercomputer Center. They've been doing a lot of work, particularly around life sciences applications. In Europe, I mentioned Cambridge. The University of Pisa in Italy has been doing a lot of base technology testing for us. So they were testing NVMe and Optane before anybody else had them, for example. The Center for High Performance Computing in South Africa is a little bit different one that's really oriented around the development of HPC in Africa. And it's really an inspiring program in terms of the way they're developing an HPC presence, not only to do research, but to develop industry and research in the community in South Africa for economic development. And that little HPC Wire award on the side there was a collaborative program actually with TAC and San Diego, whereas we were updating systems at both of those locations, the old systems from those sites were donated to South Africa to then be deployed in other locations in Africa to basically foster HPC development in the continent. We're doing a lot with the Chinese Academy of Sciences, again with the development of HPC there, huge programs going on in China. And again with OpenStack, there seems to be a large level of activity around OpenStack in Australia. Monash University, we've published a number of application notes on their use of OpenStack. And as I mentioned, CSRI just joined. I also wanted to highlight, again, it fits in with the storage discussion here, again, the work that we've been doing with Cambridge. And so, again, with the combination of Dell and EMC, we have a rather broad storage portfolio that we're able to leverage for HPC. We've been driving, of course, some of the fast scratch capabilities around Lustre and so on, and so we have our ready solution for HPC Lustre storage, and as well as the HPC NFS storage solution. Those have been around for a while, but we just updated with our latest storage array. But then also coming in from the EMC side, Isilon and Elastic Cloud Storage, which gives us pervasive project level storage, as well as object storage for very, very large volume archival purposes. That also, by the way, sort of integrates off to the right of this chart with storage archiving capabilities that we can do automagically into VirtuStream, so that we can really do sort of an end-to-end fast scratch out to the cloud. But the most recent work, what's dubbed here the Dell EMC Data Accelerator, is bringing the capabilities to accelerate I/O using NVMe-based storage. And that's the project, there we go. That's the project that we've been working with Cambridge on. And this is a program that they've been doing the development, sponsored by us and by Intel, to build out the software infrastructure to enable NVMe support, like a burst buffer and so on, when using Lustre and other file systems. So using standard Dell EMC hardware, the PowerEdge R740XD is a standard 2U, 2-socket server. What makes it a little different is across the front, you can install 24 NVMe drives. So you can pack an enormous amount of data into a very small footprint. And you see a basic Lustre configuration there in the diagram with an MDS and an OSS all implemented in the NVMe drives. This was, they sort of had a first benchmarking exercise for this just in time for the IO 500 benchmarks back before supercomputing, and managed to place #2 behind Oak Ridge using this technology. And our plans is then to productize this further, again, as a standard solution and offering from Dell EMC. My last part of this is a shameless plug. We just had our Dell EMC HPC Community meeting last week in Austin. Had a great crowd getting together. And again, this is part of our collaboration with our customers. We're really driven by what our customers are really asking us for, and the collaboration with them on the development of new technologies. We meet 3 times a year. The major meeting is the one in Austin in the spring, the meeting last week. But we'll also be meeting the day before ISC and the day before SC coming up, and you're all welcome to participate. You don't have to be a Dell EMC customer, although that helps. You do have to have an NDA with us, however. But you can track the progress of the meetings at www.dellhpc.org. And with that, I'll happily take any questions. Miraculously on time.